Good morning, everyone, and thanks again this year for your interest in joining this little font session. I'm Dominik, I work on the layout team in Blink, and I'm going to talk about shipping variable fonts in Chrome today. We're going to talk about what are variable fonts and how do they work. There will be a little bit of a hands-on session. Let's make a variable font. Then I talk about how variable fonts are integrated into CSS and the details of how we implemented them in Blink. So OpenType variable fonts, what are they? There's something like this. So what you see here is the two examples of variable fonts that Google commissioned from a type design company. These are Amstelvar and Decovar. And you see here, these fonts, they don't only scale in size. I mean, these are fixed size, but I could scale them vertically, like you know. You can change the font size, but here you can also change other axes, as they're called, of the fonts. So you can, for example, change the thickness or the contrast of the thin and thick parts of the letter shapes. And the Amstelvar version here, it scales mainly in weight and width. And the Decovar version has even additional changes, like the serifs are changing or the outline of the letter shapes.
In thickness and variable in thickness and what outline?
Thickness and width, all kinds of axes. I'll get into a bit more detail.
Okay.
So one of the canonical axes that can scale in variable fonts is the weight axis. So you can scale letter shapes from thin to very bold or black shapes. Here we see an example of additional shapes or sort of axes in which the letters are changing. This is a graphic or an illustration from the OpenType variable fonts announcement when the new standard was introduced. So variable fonts are an extension to the existing OpenType standard and were introduced in ATypI 2016. So here it's scaling, the font is scaling from narrow to wide and from light to bold, and also vertically the contrast is changing. So the contrast is the difference of the ratio between thin and thicker parts of the letter shape. Variable fonts give new advantages or new ways of typographic expression. You can do more with the same sort of font file, and they're all stored in one font file. So, for example, if you need Roboto in several widths or in several thicknesses, you don't need to download multiple font files anymore, and it's all in one file. So that has the potential of saving bandwidth. And with variable fonts, you can also extend responsive design on the web to typography. So, for example, you can adapt the amount of space the font takes on the screen according to your screen size also, and fluidly scale. So how does it work? As I mentioned, it's an extension to the existing format. And what we have here is the outline of the letter or the glyph B of the Roboto font. And I took this from the thin version of Roboto. And this is what it would look like in a font design tool, like, for example, glyphs. And what you see here is the contour points of the TrueType outline. So variable fonts work by adding vectors to these contour points, displacement vectors in a way, or vectors that modify where the contour points are. And between the start point and the end point of these vectors, you have a linear interpolation. So if you think about where these vectors are pointing to, you might already recognize that they're pointing towards the bold version of the letter. I can go back and forward. So if you imagine linearly interpolating between the start and the end point, you get all the different versions of the B between thin and bold. So I'm going to show you a couple of variable font demos. So this is all running now inside inside the beta version of Chrome. Here we have the Noto Arabic font, scaling from thin to bold, and also changing in width. And you see that even these sort of diacritics here on the top, or these marks at the top, they are also moved into the right position. So it's not only about shaping or changing the glyph outlines, but it's also about where combinations of glyphs are placed. So this is the example that I used on the slides. So this is running here in the browser now as well. Here we have an example of a variable font that Adobe made. These are just the dollar and the cent sign. And what's interesting here is that you can also have changes in the glyph shape completely. So when you move to a very bold weight, then you don't want the vertical stroke here through the glyph. So you can use different glyphs depending on what your axis parameters are. But it can also be other parameters, not just the weight and width, but decorative elements. For example, with this Buffalo Gull font here, I can change this cookies slider, and you see that these decorative elements are changing. Or I can move this and have these round or spiky fringes on the letter shapes. So what this shows is that the designer can choose what these variation axes are. So the font designer can make a design that varies in all these sort of axes, and they're free to be defined by the designer. Okay, yes?
So are these axes are these standard things, like cookies are a standard font idea, or you define anything you want?
So there's two sets of axes. There's a couple of canonical ones or standardized ones, like weight, width, slant, things like that.
Serifs.
Serifs is not a standardized one, I think. I mean, at least not in this kind of variable font definition.
I thought I saw one of your early demos was moving between serifs. I thought I saw.
Yeah, I can move serifs, and that's the sort of freely designed one. That's one designer's idea of how you can modify this particular font. So there are these canonical ones that you can. And we'll get to the CSS integration part. So the weight and width and style, slant you can control through other CSS as well. And then there are freely designed ones. And how you can recognize them, they have tags, and the lowercase ones are supposed to be the ones that are already standardized, and the uppercase ones are custom ones. So moving on, I would say we try to make a variable font. So what we have here is a test font that I initially made to do some ref testing. So here we have, I started this font view preview tool, and I'm using the letter A, and the letter A here is a little bit degenerate. It's just a box. And you see no slider or anything. So this is a conventional font. It just has this box for the letter A. Now I'm using font tools to dump the binary format of the font file into a so-called TTX file, which is like an XML version of what you see inside the binary. It's a font disassembler that allows us to edit it in a text editor, and then I can run the tool again to convert it back to a font binary. So here I'm running TTX, and it's dumping the font. And what you see, it's dumping all the tables that are inside this font file. And some of these tables are about metrics and additional meta information about the fonts. But what's interesting or what's important is perhaps the CMAP table, which is the translation from Unicode code points to glyph IDs. So basically the the register of glyph shapes in the font. And the other table that's here interesting is glyph, which actually contains all the glyph shapes. So let's have a look at this file. And I'm going to look at the glyph table, and here we see the shape of this A. And it's relatively simple. It's just basically going up, to the right, down, and to the left again, roughly. So it's just, you see the sort of corner coordinates of the box that we have. But this is not variable yet. So how do we make it variable? And for this, we add one additional table, which is called the FVAR table. And here's an FVAR table that I made earlier. So we're going to the end of this file, and we're going to insert this FVAR table here. And what this table does is basically it's defining one of those axes. Here I'm going to call the axis upward, or UPWD, for one axis that we're going to use to move this box upward. I'm defining a min value and a max value, 0 and 350, which is just something in font coordinates. It's relatively arbitrary. You can define these axis values to be whatever you want. And I'm giving this axis a name using this axis name ID. And there's a separate table in the font that resolves these name IDs to real text. So we have defined an axis, but we don't know yet how the glyph should actually change. So we need to define what do we want to happen to this box. So for this, we're adding a separate table. It's called the gvar table. And I'm adding this to the font file as well. And what we're telling the OpenType layout system with this is, I want to modify the A glyph, and I want it to sort of react to changes in the upward axis, which is the tag that we just defined in the other table. And the point 0 should move vertically up, and the point 1 should move vertically up, point 2 should move vertically up. So basically all the contour points of this box should move up depending on the upward axis. And for what this means here for value 1 is that basically here the values are normalized, so between 0 and 350, what we used in the other table, it's sort of normalized to the range of 0 to 1 and then moved completely up. So we're going to save this file and run the TTX tool the other way around to generate a variable font out of it. And what you see here now at the end, parsing FVAR, parsing gvar, so these tables are now used. And now I can run FontView on our output. And now OpenType compatible tools have recognized that there is a slider for the upward axis, and I can use it to move the box up and down. And this is a basic example. It's just a box and 4 coordinates that you can move up and down, but it illustrates the principle. So you can have a glyph shape, apply these delta coordinates to it, and then the shape and rasterization changes.
Yeah, I don't know if it's how many people are familiar with typography conventions, but I think it's worth noting here that the traditional way of sizing a font is not based on when you talk about a font's point size, you're not talking about the height of the glyph. You're talking about the height of the space that the glyph is allowed to live in, and because that gives the font developer the ability to control the white space around it. And historically, if you go back to when people were hand setting type, the point size was the type of the lead block that it was on, and the glyph could vary in size inside that box.
Yes, so we've extended a conventional OpenType font from to be a variable font. And things of note are we have defined an access and we've defined glyph modifications. Okay, coming back to the slides. So now we've made a variable font. Let's see how variable fonts are integrated into CSS. This what I've looked at, or what I've shown so far, is basically how the OpenType standard works, but that doesn't apply only to browsers, but also applies to other text processing systems like Word or OpenOffice, things like that. So the CSS integration works in two ways mainly. The first integration is having this font variation settings addition to CSS, which allows you to specify those coordinates for access tags. And here, for example, the weight is 700 and the upward axis is set to 200. And here you see this difference between the lowercase ones, which are the conventional ones or the ones that are canonically registered in the standard, and then the uppercase ones, which are something that the font designer freely choose. Font weight, font stretch, font style are moving from being keyword values that are just fixed passed to becoming number values. So they can now freely be assigned any number between 1 and 1,000, for example, for weight. And this is the other CSS integration here. And now that these properties have changed, it also is also required to change what you can put in font face, because when you declare a font face in CSS, now that the font is variable, describing a font that you can download with only font weight 700 is not enough anymore. But what you want here is something like this, where you can say the font weight can range from 400 to 700, font style can range from 10 degrees slant to 20 degrees slant. Stretch can range from ultra condensed to ultra expanded, 50% to 200%. And it's also required to have a new font style matching algorithm. Previously, it was basically taking a fixed stretch value and matching it against another fixed stretch value, or finding at least the closest one. Now you need to sort of numerically search for what's the closest and see if that's in the range. So to implement this in Blink, font stretch, font style, and font weight were turned from fixed sort of token parsing styles or token parsing values to being passed as numbers. Font traits used to store these stretch, style, and weight as fixed values in a very compressed form. This has been replaced with font selection request, which now stores three font selection values. These are the numerical values for stretch, style, and weight. And font selection capabilities is storing what is declared and available in the font face. So looking at an example for the new font selection algorithm, this is the old variant. This is what it was before. So we have three font faces declared. We have Roboto in font weight 200, font weight 400, and font weight 700. And then we have a div styled to use font weight 600. So how do you find the right font? You sort of go on this gradient of font weights, start at the 600 position and see that there is none at 600. And the nearest one here is the 700. So you're searching towards the bolder ones first, and we find the 700. And in the new world, this works a bit differently. So here we have two font faces defined with ranges of font weight, a light one, which is between 100 and 300, and a bolder one, which is between 500 and 700. So now you go into the search and find that there is a matching range from 500 to 700. And then, in this range, I can actually apply my 600 styling, and then this parameter will be passed to the font. For rasterizing variable fonts, what I just mentioned is it's important that the rasterizer knows about what parameters you have applied. Otherwise, the rasterizer couldn't calculate these deltas and couldn't determine the right glyph shape and couldn't rasterize it. So what we do on the Blink side is we integrate with Skia, and we give Skia these SK font manager font parameters access values and or tags and values. So this way we pass it on to Skia. But then we have a problem, because Skia uses different font rasterizers on different platforms. It's using Cortex on macOS, it's using DirectWrite on Windows, and it's using FreeType on the Linux-like platforms, so on Chrome OS, on Android, and on Linux itself. So even if I would pass those parameters to Skia, it can't handle them on DirectWrite platforms, for example, because DirectWrite doesn't yet have API for rasterizing with these axis coordinates applied. Only this fall update of Windows 10 will have an API for this, but any previous versions of Windows don't have it, and also older versions of macOS don't have it. So what do we do? So what we decided to do was to create a hybrid font stack and shipping FreeType on the platforms where we don't have variable font support natively inside DirectWrite or inside Cortex. So on the Linux-based systems, we are fine. So we will ship our own FreeType and continue to use that. On Windows, we now use DirectWrite for conventional fonts, and we use FreeType for when we detect a font to be a variable font. And we can do that by looking at whether it has the tables that we need for it to be variable. And on macOS, we also use FreeType in cases where we are running on older versions of macOS, like older than 10.12. And how this works is using font format specific web font instantiation. Is this web font variable? Does it have an fvar table? This is the table we added in our little hands-on coding session. If yes, do we have platform support? That means, do we have, for example, Cortex or FreeType natively? In that case, we can use the platform rasterizer, and if not, then we use the built-in FreeType. So on Windows, we will have a built-in FreeType that we can then fork towards and use. This brings also new possibilities for emoji fonts. That's something I'm currently working on, so we'll be able to use FreeType also for cross-platform color bitmap fonts. In order to ship FreeType on all platforms, we had to clean up what's been in the code base in terms of different FreeType instantiations. In PDFume, there was its own version of FreeType, which was copied to the repository. And in Blink, we had FreeType 2 and we had FreeType Android. FreeType 2 we were using for layout tests and compiling it into the content share. For FreeType Android, we had for linking it into the Android APK linking it to the executable we ran on Android. In total, there were 3 different checkouts for building Chrome, and we worked on reducing that to 1. PDFume and Blink now share the same up-to-date FreeType version, and FreeType 2 and FreeType Android were merged. And because of this sharing between PDFume and Blink, the Windows Chrome binary size without variations is the same or roughly the same as with variations. Because PDFume was already integrated or was already part of the Chrome binary on Windows, it just was an older FreeType version. So once we updated and shared this between Blink and PDFume, we did get the full functionality of a new font rasterizer at almost no binary size cost. So to recap, we talked about what are variable fonts. They are a vector format that is extended to have deltas to extend the letter shapes and modify them. I showed you a couple of demos of this running in the browser. We made a variable font, and we talked about how this OpenType update is integrated into CSS. And finally, I talked about some details of the Blink implementation, with one notable feature being that it's running cross-platform, even on legacy platforms where we don't have native support. And this was also just announced yesterday in the Chrome 62 beta blog post. Yes, thank you. Yes, are there any questions? Can I show you something else or other things you'd like to know?
How does hinting work with this stuff?
Hinting works the same way as before. So it's compatible with hinting. Hinting is basically a program that you execute on the contours or the contour points of the glyphs. So you would first apply the variation axis parameters and extrapolate or sort of define the or compute the new glyph shape, and then you have your set of contour points that are at certain positions, and then you execute the hinting instructions on top of that, which would move them by like half a pixel or something to have them at pixel boundaries usually, or do other modifications to it, or to sort of equalize stems or so. But it all works, but it's done after you have computed the variation deltas.
Are we going to switch to native on Windows when Ford update is available?
Are we going to try? Yes. So I received a preview of the direct write headers, and I've looked at it with Ben from the Skia team. It depends on bandwidth in the Skia team, basically.
Always. It's not our, but more
it's Skia, yes. So it's the direct write backend of Skia that would need to implement. Skia receives the parameters from us, and then Skia would need to write the code to pass them to direct write and create the rasterization there. Yes, it's possible, but on the other hand, you'll probably stay with using FreeType on Windows as well if I get around to implementing the color emoji font as well.
Yeah.
Or that could be done through direct write, but yeah, it's either works.
Are there any variable fonts currently available in Google Fonts or some other?
Yes, so Google Fonts has a preview of in an alpha version of Amstelvar in it. And what I should have mentioned is this is currently only working for web fonts. So I'm not sort of scanning the platform for which fonts are variable fonts at the moment. There is starting to be platform support for variable fonts on Cortex for sure. And in this fall update of Windows 10, there will be a variable font as well. But we don't support those as fonts to be used in the browser at the moment.
Are there font editors that you can use to edit variable fonts? Or?
Yeah, the tooling is definitely something that's very much in progress still. There are some font editors that have initial support for it. For example, there's Glyphs app on Mac where you can partially do modifications. But the way the tooling currently works is mostly that you define several so-called masters. So you would make a thin variant, and you would make a bold version or a black version or like other versions on the spectrum. And then you use tools like font tools and other tools of the open source pipeline to define, okay, this original font is at coordinates, let's say 200 weight, and this black version is at coordinates 700. Please combine this into a variable font. What's important is that the two originating fonts need to be what's called point compatible. So if you, for example, think about this B glyph shape, you cannot have a B with a different number of points than the new B, because then the tools wouldn't find any way to compute these delta. So it's not like morphing between forms, but it's really shifting the point.
And the only possible transformation is this delta that you mentioned.
Yes, there's only these transformations are only these deltas, but you can have multiple dimensions of deltas. So you cannot have them only in one way, but you can, onto each point, you can have attached you can imagine like a whole star of different delta vectors that push it in different directions depending on those axis values.
Is there any differences between TrueType and CFF?
Yes, there are differences, but the main difference between TrueType and CFF is the way the contours are defined, as far as I know. But TrueType outlines are using quadratic Bezier curves, and the CFF fonts are using cubic Bezier curves. But the delta principle works the same way. So the points are moved with deltas. I think that's the same for CFF.
So the table itself is common, same.
Yeah,
same
like
for
I think
both.
the two main tables we saw, the FR and the GVAR tables, are common for this.
That's good.
Okay.
Thank you very much.
Thank you for joining.